All right, chapter 5.6, graphing linear. I'm not going to do this over. Chapter 5.6, graphing linear inequalities into variables. I got it that time. But I am not starting over. Okay, so you know what I mean by I'm not starting over, meaning I am not going to re-record. That's what I meant, because I've started over now like twice. Now I'm going to start over again. Chapter 5.6, graphing linear inequalities in two variables. Woohoo! All right, I put these pictures up because that story problem page you had has one story about basketball, has another one about roller coasters, and has another one about cookies. Yay! And you know I'm always looking for pictures to put up on my lessons. All right. Questions. You're not here, so you don't have any questions. All right. Is 4, -3 a solution to x plus y equals 5? This should be pretty easy. We're just going to put 4 and -3 in here. So 4 plus -3, does that equal 5? No, Mrs. Oldham, you silly goose, it does not. So I actually have people in here today. So, but they're not SM1 kids. All right, so let's look at this one. Okay, here we have 4, -3. Is it a solution to this problem? So it's identical, except now I have an inequality symbol instead of an inequality symbol instead of an equal sign. That's what I'm trying to say. Okay, so I have 4 plus -3. Is it less than or equal to 5? And the answer is yes. 1 is smaller than 5. Okay, so what we're going to talk about today, well, the reason I'm having you do this is partially because it's in your homework. But it says, tell whether the ordered pair is a solution of the inequality. And I know this is a try this, but I'm just going to go ahead and do it. So I plug in, this is x, this is y, and I plug them in and see if the inequality is true. So 2 times -1 plus 9, is it less than -3? Well, we've got -2 plus 9. Sometimes I put little question marks above here. So we've got, you've got to be kidding me.
We would like to invite all faculty and staff who have not yet received their gift from the main office to please come to the main office now.
Should I pretend like I didn't already get my gift? Because I did get my gift. No, that would be bad. Okay, 7 is less than -3. That is not true, all right? So this is no. Okay, over here we plug in, again, here's x, here's y. This is 2 minus 3 times -2. We want to see if this is bigger than or equal to 8. So I've got 2 plus 6 greater than or equal to 8. Is 8 greater than or equal to 8? Yes, because I have that equal part in there. So that is true. Okay, and now if we were to graph these, actually I'm not sure why I have this slide on here. I thought I knew, and I thought it made sense in my head, but now it doesn't, so oh well. Okay, so let's graph this. We have y equals x minus 1. So I have -1, and my slope is 1, which is saying 1 over 1. So I go up 1, over 1, and I keep going that way. And so here is my line. And if you're still having trouble knowing how to graph a line, please come see me, because it is really critical that you know how to do that. Okay, so there is my line. All right, so let's look at another one. What if we change it up just a little bit and we make this y is bigger than or equal to x minus 1? How do I do this? Well, the way that you graph an inequality is, first of all, you graph you pretend that this is an equal sign. All right, and it gives me my boundary line. All right, then what you need to do is you need to pick a point on the graph. I'm going to pick 0, 0. And what I'm going to do is I'm going to plug 0, 0 into this inequality. So I have 0 greater than or equal to 0 minus 1. I'm asking myself that. Is 0 greater than or equal to negative 1? And the answer is yes. So that means that 0, 0 is a part of my solution. Well, this is my dividing line, okay? That's my boundary. And 0, 0 is a solution, so that means that this whole half, all of this would be shaded in, because all of that all of those are solutions. So I could pick, like, let's say I pick, well, let's pick, to show you how this works, let's pick 2, 0 right here. Okay, this is in a section where it shouldn't work. Any of these points over here should make this inequality not true. So if I plug in 2, 0, have 0 greater than or equal to 2 minus 1. Is 0 bigger than 1? No, it's not. So it makes sense that this side of the line is not shaded. I hope that's making sense. Okay, so let's say I switched it again. Okay, again, it's the same, very close to being the same thing. I have my border line. That's when I change this to an equal. That gives me my border, okay? I'm trying to think of another name for, anyway, my line. All right, now, again, I'm going to try 0, 0. And I bet, since this thing flipped, see, this was the last one, here it is now. Since it's flipped, I bet the other side is going to be shaded. But let's try 0, 0. So I plug in 0. Is 0 less than or equal to negative 1? And the answer is no. So 0, 0 is not a solution of this, which means the other half has to be. So I would shade in this part of the equation. And again, you could pick any of these points. You could pick 100, negative 100, and it would work because it's all on this side of this line. Okay. So you might, I'm not a huge fan of step-by-step instructions, but you might want to pause the video and look at this. It says how to graph an inequality. First you graph the boundary line, dotted or solid. So it's a solid line if it's less than or equal to or greater than or equal to. It's a dotted line if it's like that. Okay? So remember, solid line, you have a solid line under there. So if that helps you. Okay, choose a reasonable coordinate point, like I did with 0, 0, and plug it into the inequality. If the inequality is true, shade that side. Shade the side the point is in. If the inequality is not true, you shade the other side. So I have a little bit more, and I will do that in the next video.